Hi, I'm John, and this is my video about software development principles. In this video, I'm going to be looking at the solid principles for software development. I'm going to be looking at what is solid, why we would follow solid and some of the benefits, and then exploring each principle individually. As we go through the principles, I'm going to be using the real-world example of a library management application in .NET to provide some examples of what would violate each principle, why it would violate the principle, how we would instead meet the principle, and what are the benefits of doing so. So what is solid? Well, solid is 5 principles for object-oriented programming languages. These were introduced by computer scientist Robert J. Martin in 2000, and he's known in the industry as Uncle Bob. Following these principles are not always straightforward, but they provide a number of benefits I'm going to explore now. So following solid helps ensure standards, consistency, and because they're widely recognised practices known to developers, they can enhance team collaboration. They promote modularity, scalability, testability, and reusability. It also promotes reduced coupling in our application and the isolation of responsibilities. So as we dive into each principle, the examples of a real-world scenario are going to be around a library management application. And this is a simple .NET application with a web front end that is used to manage books, book loans for adults and children, users and their borrowing limits. So looking at the S in solid, this is for single responsibility principle, and this says that a class should only have one reason to change, and this means that a class should only have one job or responsibility. It means, for example, that a class should not contain a mixture of actions related to different objects, and it should only have one reason to change. So as a real-world example around our library management application, there is a class called book service containing methods related to managing books. We would violate SRP by adding methods related to managing users to the book service class. The way that we could instead meet SRP is separating users and book loans into separate services and classes. By doing this, it ensures that book service class only has one reason to change, and that is that the way of managing books changes. And the benefits of this is that it makes code easier to navigate and understand. We have isolated responsibility for users, books and loans. And it means that if we make changes in one class, such as the book service class, we're not going to as easily introduce bugs in unrelated features such as user management or vice versa. The next principle is O for open-close principle, and this says that software entities such as classes, modules, functions, etc. should be open for extension but closed for modification. Ultimately, you should be able to add new functionality to your application without modifying existing code. Going back to the example of our book service class, we have in there a method called getBooks, and this retrieves all books from the database. It would be a violation of OCP to modify the existing method getBooks to filter by genre when retrieving those books from the database. What would instead meet OCP is adding a new method, getBooks by genre, which gives us that behavior we want. In conclusion, book service is open for extension but closed for modification. So it's open by extension for adding that new class getBooks by genre, and we're not modifying any existing methods, which means it's closed for modification. The benefits of this again are reduced risks that we will introduce bugs in this example. If we have other methods in our application that called getBooks, and then we start making changes to getBooks, we could introduce unexpected behavior in other parts of the application. Whereas by defining a new method with this new behaviour that we need, and then only using it where it's required, we're reducing risk of introducing bugs into the application. The next principle is Liskov substitution principle, and this means that a subclass must be substitutable for its base class. In the example of our library management application, we've got a class called library member that has two subclasses, adult member and child member. Adult member and child member each have a method can borrow, and the rules of the business are that children can only borrow if they don't have overdue books. We would violate LSP by adding a new class, guest member, that doesn't override can borrow and adds a new method, can borrow, if accompanied. And the reason for this is that if another class, loan service, tries to use guest member when it's coded to use adult member, child member, or library member, then it may lead to unexpected behaviour. The benefit of not violating LSP is that it leads to a more robust and maintainable system. It ensures that a superclass and its subclasses can be used interchangeably, and you can rely on the behaviour of the base class whenever working with any of its subclasses. The next principle is the interface segregation principle, and this says that no client should be forced to depend on methods it does not use. As a real-world example, loan service class calls methods for managing loans, but it doesn't need to use methods related to managing users. It would violate ISP to create a new interface, iLibrary member, that contains a mixture of methods related to users and book loans. And this would violate LSP because loan service would be forced to depend on that interface which contains methods related to loans and users. So it would effectively depend on methods that it doesn't use, and that is the methods related to managing users. What would instead meet LSP is separating iLibrary member interface into smaller interfaces, one that contains actions related to users, one that contains actions related to loans, and then loan service can just depend on the interface that it requires. The benefits of this is that loan service isn't forced to depend on methods it doesn't use, and it makes the system more modular and easier to understand and maintain. The final principle is the dependency inversion principle, and this says that high-level modules should not be forced to depend on low-level modules. It also says that you should depend on abstractions or implementations instead of concrete classes. So in our real-world example, we've got a notification service class that is responsible for sending emails to users. It would violate DIP if notification service depended directly on the concrete class email service to send emails to users. And this would be problematic because if we needed to later add SMS, notification would need to be modified, which would mean modifying existing code and the inherent risks that come with that. Instead, we could add an interface iNotification service that implements email service, and then notification service would use iNotification services to inject email service. The benefits of this is that we could later come along and modify or add new notification methods such as SMS, or modify that existing email service without needing to change code in notification services. And this would make the system more flexible and easier to modify in future. That concludes my presentation on software development principles. Thank you for watching.